Hi everybody, so we're going to try to look at the how secure this Wells Fargo bank account password is, and if you click here you'll see this is a real password requirement. You must have at least 8 characters, and it must have 3 of the 4 requirements below. And so we're going to try to estimate how secure this password would be if you pick the shortest and least secure password allowed by these rules, right? So first of all, we need to satisfy 3 of the 4 rules. So press pause on your video and try to figure out which 3 of these 4 would you satisfy if you wanted to just make up the least secure password possible that would be allowed. Okay, I hope you tried to do that. I'll talk about it now. So you would definitely pick, a number, an uppercase character, and a lowercase, because these have the least of the 4 options. These have the least amount of options by group, right? So but you must have 3 of the 4. So you must have at least 1 lowercase character. So that's 26 options. You must have at least 1 uppercase character. That's 26 options. And you must have at least 1 numerical character. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 options. So altogether, you would just choose from these 3 groups, and that is 62 characters altogether, right? Now, your password will be how long? If it's the shortest and least secure, how long would it be? It would be it needs to be at least 8 characters in length. So we'll make it exactly 8 characters in length to find the least secure password, right? Now we've got small lowercase ABC, we've got uppercase ABC, and we've got digits 0, 1, 2, 3, and so on, right? So if our password was just 1 character long, like the letter S or the number 5, how many possible passwords could it come up with if it was just 1 character long? So press pause on the video and tell me how many possible passwords if it's just 1 character long. That's the key. If it's just 1 character long, there are 62 possible passwords. Does that make sense? That is the key to understanding this question. 62 possible passwords. If our password is 2 characters long, so it's just going to be 2 characters long, okay? How many possible passwords would we have then if the password is 2 characters long? In other words, if it's something like ST or 3R or whatever. And of course, this isn't satisfying the rules because our password needs to be 8 characters long. It has to have 3. It has to have at least 1 number, at least 1 uppercase, at least 1 lowercase, right? But just for fun, figure out this math problem here. If the password is 2 characters long, how many possible passwords are there? Like, how many possible combinations are there where in each spot I'm putting either a number or a lowercase or an uppercase, and the next spot I'm putting number, lowercase, or uppercase, right? So the answer is there's 62 ways to make the first character of either lowercase, uppercase, or number, right? And there's 62 ways of making the next character. So the first character could be 0, 1, 2, or 0 or something, and the next character could be F. Or the first character could be capital R, the next character could be 5, right? Oh, sorry, or Y or something, right? So the answer is there's 62 possible ways of making the first character, and adding on to that, you can have 62 other options for the next character. Now, 62 times 62 gives us 3,844. So the answer is there are 3,844 ways of making a 2-character word with these conditions. You've got to have, you're choosing from upper, lower, or digits, right? So last one for fun, if our password is going to be 3 characters long, how many possible passwords would that be? And just press pause on the video and figure that out. Sorry, 3 characters long, not 2. So password is going to be 3 characters long. How many possible passwords? Okay, I hope you tried it. I'm going to go over it now. You're going to have 62 possible characters in the first spot, 62 in the next spot, and 62 possible characters in the next spot for a total of 238,000 possible characters, right? For a 3 character long password where we're just choosing lower and uppercase letters and numbers, right? So the question then is, and by the way, how did we get that? 62 times itself 3 times is also 62 to the power of 3. And we use a little hat symbol on your calculator later for the exponent, right? 62 to the power of 3. So then the question is, well, how many possible passwords can we come up with if our password is going to be 8 characters long? So press pause on the video and do this. If your password is going to be 8 characters long, how many possible passwords? Well, it'll be 62 times 62, 8 times. Okay? That's 4, 5, 6. Sorry, 6, 7, 8. Okay? 1, 2, 3, 4, 5, 6, 7, 8. Right? That. Or simply 62 to the power of 8. That's what it would be. 2.183 times 10 to the 14, right? So big long number, right? So that's the number. Just for fun, what does that look like in real life? I'm just going to go 2 with 14 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the number looks roughly like that. Something like 218, okay? And if I put commas in, I might be able to actually read this number. So it's 1,000, million, billion, trillion, 218 trillion. So there's 218 trillion possible passwords, right? 218 trillion. All right. So in any case, we take this number, and that's the exact number there. And that's the number of possible passwords we can make that are 8 characters long under these conditions. Now, our hacker can guess 100 billion of these every second. That's 10 to the power of 11. And I'll look 100 billion. What does that look like? 100, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. That is what 100 billion looks like. So we take our 218 trillion and we divide by, we divide that by 100 trillion, or we can just 6 to the power of 8, 6 to the power of 8 divided by 10 to the power of 11, right? So that's like our 218 trillion over our 100 billion, and we get this number, 2183. Now press pause in the video and tell me, what does that number mean? 2183, what does that mean? Okay, I hope you've thought about it. What that number means is we've taken our, I should do that. 218 million possible passwords, and we've divided by 100 billion guesses per second, right? 100 billion guesses per second, and that means it will take this number of seconds to guess all of these passwords, okay? And so that's what that means. That's 2183 seconds for the hacker to guess all of those passwords. So how long would it take the hacker to brute force guess the password? 2,183 seconds. But give your answer to the nearest minute. Well, let's take those seconds and divide by what to get to minutes? How do you go from seconds to minutes? I'll give you an easy one. What's 120 seconds to minutes. So if you have 120 seconds, how do you get that to minutes? Divide by 60, right? Because it's 2 minutes. 120 seconds is 2 minutes, right? So 2183, it's actually 0.4, right? 0.4 seconds into minutes, divide by 60. And it's 36.39 minutes, okay? And it says round to the nearest minute, 36 minutes. Just that's 36 minutes, right?